Hey Algebra 2s, here's a key for last time's homework on 3-3. We did 3-2 and 3-3 together. 3-2 was graphing and 3-3 was solving. So this will be a good review for you before your quiz. Alright, if we need to write the new function created by the given transformation, we're going to sketch the graph, mark the zeros, and give its vertex. So everything at the same time. Ready? Translated horizontally 3 units to the left and vertically stretched by a factor of 2. So it doesn't seem like it's moving up and down. So if when we talk about this vertex, it's going to be 3 units to the left. 1, 2, 3. And if it's stretched by a factor of 2, we're going to have your graph come up super fast. So it's going to be a skinnier graph for sure. Alright, so my vertex is going to be over -3 and up 0 because I don't have a vertical shift, just a vertical stretch. So I can write my function in vertex form. I can say y is equal to, remember every time you write an equation, a y is equal to, and this left is going to be represented by that naturally negative, so it's minus -3, which is going to come out as plus 3 squared, and this stretch of 2 is going to be right in there. So we can talk about the different xy ordered pair values. The easiest way is to enter this equation into Desmos or into your graphing calculator. So if I get my graphing calculator out, I can go ahead and say y is equal to 2 times x plus 3 squared. I can look at my graph to know, yep, I'm pretty good there. I can go to my table of values, and my table of values is going to give me all of these input-output values. I like to put my vertex in the center of my graph so that I can see that symmetry. You can do the same thing with Desmos if you go into Desmos and enter the equation. So I know that -3, 0 is my vertex. So I like to go to values bigger, 2 and 8, and 2 values smaller, -4, -5, and notice the symmetry in my table. Alright, let's check out the next one. Reflected across the x-axis. So this reflected is going to represent, we're going to have a negative out in front. So we'll go ahead and start our y is equal to, translated vertically 4 units down and horizontally 3 units right. So 4 down and 3 units to the right. So if my vertex was at 0, 0, 1, 2, 3 to the right, 1, 2, 3, 4 units down, and remember it's reflected, so my graph is going to be down like a frown. My vertex is going to be +3 and -4. So this negative is going to make sure that my graph gets flipped. And this +3 is in my naturally negative spot. And this is true to sign as it goes down. And I can do the same thing with my graphing calculator. We'll go ahead and clear out the old one. I can say the opposite of x minus 3 squared minus 4. Enter that in, go to my table of values. Now you can do the same thing with Desmos. And I know I'm looking for a vertex of 3, and I just love seeing this symmetry here. Here's my vertex of 3, -4, and I can go a value bigger and smaller in each direction. A 1 goes in, -8 comes out, a 2 goes in, -5. Here's my vertex here. 4 goes in, negative 5 comes out. 5 goes in, negative 8 comes out, and I can see that symmetry there. All right, next one, graph the function, mark the zeros, and identify its properties, round to 2 decimal places if needed. So we'll go ahead and recognize we have a reflection because we see that, and we have a shift to the left of 4, and no vertical shift. So 1, 2, 3, here's my vertex. It's going to open down, so there it goes. I can get my table of values by going ahead and we'll make this x plus 4 squared, and we don't need any shift. When I look at the graph, there it is, and I can go to the table of values, and like I said, I like to go ahead and put my vertex value right in the middle, and then I can see those values above and below. So negative 4 goes in and 0 comes out. I can go 2 points in one direction and 2 points in another direction. Negative 4, negative 1, negative 1, negative 4. All right, let's talk about these transformations that we see. We're going to definitely have a reflection. And we're going to go to the left 4. My vertex is over negative 4, up 0. My axis of symmetry is going to be the x is equal to equation that goes right through my vertex. It's going to be a vertical line, so it's going to be a vux, which is always an x is equal to equation. So your x is going to be always equal to that x value of your vertex, so x is equal to negative 4. My maximum is going to be this vertex because it's down like a frown. And my relative minimum, I don't have one. My domain, all real numbers can go in, but what's coming out is going to be negative infinity up to and including 0. My x-intercepts also happens to be my vertex. My y-intercept is what's going to happen when I put 0 into the function. And there's 2 ways of doing this. I can just substitute into my equation. 0 plus 4 is 4. 4 squared is 16. The opposite of that is negative 16. Or I can look back at my calculator and I can say, hey, what happens when 0 goes in? Negative 16 comes out. My graph is increasing. My ant is climbing uphill from negative infinity up to, but not including 0. Oh, not 0. Negative 4. Oopsie. And remember, your intervals are always about x's. And then just after negative 4 on forever and ever, it's going to decrease. As my x's get infinitely smaller and bigger, the output is continuing to always go down to negative infinity and get smaller. All right, let's check out number 4. For number 4, I have another negative graph, another reflection, and this one's in standard form. So for standard form, I know I have my a is equal to negative 1. My b is equal to negative 2, and my c is also equal to negative 2. When I want to find my vertex, I do negative b over 2a. So my x-coordinate of my vertex is going to be the opposite of negative 2 over 2 times negative 1. There's a lot of negatives going on there. So my x-coordinate is going to be negative 1. So I know at least for my vertex over negative 1, and I know my axis of symmetry is going to happen right here at x is equal to negative 1. Get my graphing calculator out, and I'll enter in the opposite of x squared. minus 2x minus 2. Again, maybe you're putting this into Desmos. Hopefully you see the same graph I do. Go to your table of values and go ahead up to -1. And there's that beautiful symmetry we see in that curve. So -1 is going to be where my vertex is. And I can go -2, -3, 0, 1, and -2, -5, -2, -5 as I fill in my table. All right, so the rest of my vertex here is -1. And my graph, remember, is down like a frown because of my negative leading coefficient. So my maximum is going to again be my vertex. My minimum is going to be none. My domain, all numbers can go in, but for coming out, everything from -infinity and up to and including -1 is going to be what's coming out, because here's the ceiling of my graph. This graph does not ever cross my x-axis. My y-intercept, when 0 goes in, -2 comes out. My increasing interval is going to be from -infinity up to, and then at -1 is where it starts to then go back down. And again, my end behavior, as my x's get smaller and bigger, my output is getting smaller infinitely so.